Today was a combo lesson. And I know it took the whole hour, but like we just needed to do it so that we have time to test and retest by Thanksgiving break, like before Thanksgiving break. So what you need to be able to do now that you've gone through the lesson is be able to look for patterns in two-way tables and relative frequency tables to see if there's a possible association or relationship between the two variables. So do you think that you could do that? That given a table, you can see, like, is there a relationship based on the numbers? When one increases, does another one increase? When one increases, does the other one decrease? That's basically the two options. And then if you can't tell, that's why you should make the relative frequency tables. You'll see that on your practice when you get to it. So if you can't tell, make the relative frequency table like we did in the lesson. Then you can compare them more easily. If you don't see a pattern, then there's probably not a relationship there. All right. Then being able to describe rate of change, which is another way to say slope. Being able to describe slope and y-intercept for a linear model in everyday language. So like what we did toward the end of the lesson. What did we say the slope of 0.18 was supposed to represent? So here's a really easy way to simplify it all the time. In every single linear model, slope is always your rate of change. Whatever situation is going on, whether it's like ice cream sales versus temperature outside. Rate of change is how much it's changing by. So like as ice cream sales increase, temperature increases or something like that, I don't know. As temperature increases, so does ice cream sales. And by how much is your slope. So what is the 0.18 representing in that situation about the oranges? All right, so we're not moving on until someone can verbalize that, because that was one of the learning parts. And we interpret slope and y-intercept in context of the situation. So when we found the slope to be 0.18 what? Harley? Well, that is your slope. But what does it mean in the real world situation? Slope is our rate of change always. But what is changing? Okay, so the weight is changing. And by how much? Every time one orange is added to the box, the weight is increasing by 0.18. It's increasing because it's a positive slope, right? Every time we add one more orange, the weight's increasing by like 0.18 on average. That's what that means. And whatever situation it is, filling up a pool, whatever, the slope is going to be how much for every like one increment on that. Make sense? Maybe? That's your rule of thumb. Slope is always rate of change. Your y-intercept is always your starting amount. Always. In every word problem, every situation, slope-intercept will be what you're starting with. So in this situation, I'm starting with what? There are 0 oranges. How much did the box weigh? 0.6. That's what our y-intercept is. It's the weight of the box when there's no oranges in there. Starting them out. Just like that last test question that we did recently. The starting amount was 60. There was like 60 gallons in the pool already. That's why that was our y-intercept. So every single word problem. Slope is rate of change, y-intercept is starting amount. And then just be able to relate it with whatever situation is going on. That's something you'll be asked on this coming up test too. So that was one of the learning targets. The last learning target is to be able to draw a linear model that fits the data well. And we even did an additional lesson in the math lab to practice that, if you were able to participate in that. So it has to go through the data, not above it, not below it, through the middle of it, where all the data is like clustered around it. And then be able to estimate slope and y-intercept and use that linear model to estimate whatever you want now. So now that we did that in the notes, I am able to estimate when there's 11 oranges, that weight approximately. All I have to do is put that in the calculator. Or when there's 50 oranges, same thing. Or if there's 20 kilograms on the scale, how many oranges are there? We can figure that out too. So that's all today. Tomorrow we'll practice it more, the linear models in tomorrow's lesson. But today, you guys need to practice by using these two puzzle pieces. They're separate, but they're both really short. So 4 questions and 5 questions, all based on today. Ask questions as you go. But otherwise, like, that's your points for the day. 80% or higher on both, or work on other things that you might prioritize more for math, like maybe you scored that on the math lib, or still missing a minor check, I don't know, but this is your hour of the day to get that done, so make sure that we're being productive. Questions on that? Okay, because really the end of the unit will be like before you know it. So make sure we're ready. Amazing. I'll do those to the side. And that's the note sheet you can make too.
You have any cans for the canned food drop?
I do not. In the slides will be a video. I'll link it if it's not in there yet. I'll put the notes in the school review. Use it electron on. And now those are the assignments for those lessons.
This one's a good question. It's really similar to what we did in our notes. So an automobile dealership keeps track of the number of cars and trucks they have for sale, as well as whether they are new or used. Based on the data, does there appear to be an association between the type of automobile and whether it is new or used? Complete the following to explain why or why not. So just looking at these numbers, it's hard to tell because they don't have the same amount of cars and trucks. So like easily you look at it and be like, oh yeah, they totally have a relationship. So that's why in our notes, what they did with one of the tables was they made it a relative frequency table. And they did it based on the column total. And that happens to be what we need as well, because if you want to be able to compare them, you need to see like how frequently it occurs within the amount that they have. So for example, the total amount of cars, and I just remember this from earlier, so correct me if I'm wrong, but it was 1,234 when I added that together. And then for the trucks, it was 284. Okay, so then when you make your relative frequencies, you would be doing 812 divided by 1234. So 812 divided by 1234. And you get a decimal, times it by 100%. And then let's just round to the nearest percent. So in this first box, that is 66% of the cars on their dealership are new. Okay, then we want to see
how many of those cars are used that remain in the dealership. So you have two options. You could do 422 divided by 1234 to get the decimal percent. Or you know, it has to add up to 100%. So 100 minus 66 is 34%. So we know out of the cars, 56% of them are new. 34% of them are used. Now compare that to the trucks. But in the trucks, there's only 284 total. So out of the 284, 233 are new. So divide that. You get a decimal, times it by 100 to get the percent. That's about 82% of the trucks that are on the lot are new. And then what remains would be 18%. I'm going to do 51 divided by 284, which is how you normally do that. I know 82% of them are new. What remains 18% must be used. So do you think, based on those numbers now, do you think that there's a relationship, an association between like whether they prefer them to be new or used for their intensive cars? Or would you say like it's about 50-50 either way? So there does or does not appear to be an association. What do you guys think? Based on these values. There does appear to be an association. Why? Well, out of all the trucks that are there, the majority of them are new. So that means that the used ones seem to sell pretty fast. These other ones, like, there's less of a big difference. But like, because this is so like drastically different, that might be like a trend. Okay, so about the length of the cars at this dealership are new. So what percent of the cars are new at the dealership? 56. But about the length of the trucks at the dealership are new. 82. The much greater percentage of trucks that are new does or does not appear to suggest a relationship. Right, so that's how you go about that one. And let me make sure the key is right. It is. Earlier the key was wrong, so I have to fix it. But that's how you figure that out. It's easier to compare them when you have the percentages versus just like numbers. Questions on this one? Other questions? Nathan? On the lesson 3 practice? Okay. So we're gonna look at number 4 now. Several college students are surveyed about their college location and preferred locations for a spring break trip. What percentage of people okay, this is one of the ones where you have to read it closely. Anytime it says what percentage of, usually what follows that is what you need to divide by. Okay, so of the people who prefer to spend spring break at the beach, figure out how much that is. How many people prefer to spend spring break at the beach? What 2 things do I need to add? Well, tell me the number. Tell me what 2 number letters to add. Okay, 37 and 54. Would give me my total of people that prefer the beach, which would be 91. And the reason why that's important, because we want to know of those people who prefer to spend spring break at the beach, we want to know the percentage of who would rather go to a college away from the coast. Okay, so how many people of these beach break people want to go to college away? So then divide that out. The hard part is knowing what to divide. So anytime it says out of these people or among this group of people, that's what you divide by. And then it's 54 divided by 1. I get a decimal. If I want the percent, which it looks like my answers are in percents, I'm gonna times it by 100. And I get about 59%, which is an answer option. And it's closer to the 59 than the 60, because it's 59.34. All right, our rounding rules. Underline where you need to round to, look to the right. If it's 0 through 4, the number you underline stays the same. If it's 5 through 9, then you round up. If it's a 3, I keep it as 59. Okay, so there's that part. Questions on that part? Okay, then what percentage? So of the people who prefer to spend spring break skiing, so determine how many people total want to spend spring break skiing. Which things do I need to add? Okay, good. And that'll give me 60, right? Okay, so out of 60, how many want to go to college away from the coast? 36. So out of those 60, 36 want to go to college away from the coast. Divide that now. Times it by 100. And that's an even 60%. Let's make sure that's right on our P. And occasionally there's errors. If you think I made a mistake, sometimes I do, but that is right. 59% and then 60%. All right, other questions from any unit 3? Jaden? Number 3 on this one. This one, a survey is given to 1,432 people about whether they take daily supplemental vitamins and whether they eat breakfast on a regular basis. The results are shown in the table. I normally always take vitamins, but then I stopped and then of course I get sick. So I feel like there's something to that. But anyway, there's our results. True or false? The following relative frequency table correctly shows the percentage of the entire group that is in each cell. Okay. So what I think it's asking is of the entire group surveyed. They didn't say of the entire group who takes vitamins, of the entire group who eats breakfast. Like they didn't say any details like that. They just said of the entire group. So we have to go back to how many people were surveyed. All right, so the total people surveyed was 1,432. So C, if I do 384 divided by that, do I get that percent? And then we'll check 476 divided by that. We'll check them all. But if it says of entire group, that sounds like of the whole survey. So let's see. 384 divided by 1432 is about 27%, which does that say 27% right here? No, so I'm gonna say false just based on that. Let's see if it's right. And it is. That's how you know, because it didn't say of people who eat breakfast, of people who take vitamins. It didn't say anything like that. It said entire group, so people. If it didn't tell you how many people were surveyed, that's where you would have to take your totals and then add up your totals to get your grand total. But they told us in like the sentence, so that's easy. All right, questions on the other, unit three? Any other questions from unit three?